This is a very quick recap of the two trigonometric identities from AS Pure Maths. The first one, well, they're in no particular order. We have sine x divided by the cosine of x always gives us tan x. Now the angle is the same in all three cases. It's an identity because it's true for all values of x, whether we're in degrees or radians, that is always true. The other identity is sine squared x add cos squared x. When the angle is the same in both cases, that always equals 1. So there we have two identities from AS Maths that you will be using very often in A2 Maths as well. So let's use them in this following example. This is a AS Maths exam style question. Part A, show that there is no angle theta which satisfies this equation. Let's take a close look at the equation. It's got cos squared, it's got sine squared, and it's got sine. We can easily substitute away a cos squared or a sine squared for something else, but substituting away the sine is not so easy. So for that reason, I'm going to get rid of the cos squared theta. Not just cross it out, but replace it with something it is definitely the same as. So using the identity that cos squared x plus sine squared x is always equal to 1, I can rearrange that and replace cos squared theta with 1 minus sine squared theta. The question is in theta, so I must make sure I'm using an angle theta, not x. I'm going to keep everything else the same. So now we have a quadratic equation in sine theta only. There's no cosines in here as well, only sines. So expand the brackets and simplify. I've expanded the brackets. Now I'm going to collect like terms. I've collected like terms. Obviously we can see it's a quadratic equation, so I'm going to put this in a slightly different order. I want to get the squared term first in my list. I'm going to make it positive. So I've added 6 sine squared to both sides. I'm going to add sine theta to both sides, and I'm going to take away 12 from both sides. Now the question said, show that there is no angle satisfying this equation. So we're expecting to get no solutions. So it's possible that this quadratic equation might not have any solutions, but in this case it does have solutions. It actually factorizes, or another alternative is to use the calculator, go to equation, it's a polynomial equation, degree 2, that's a quadratic. So we've got 6 in front of the x squared, well the squared term. 1 is our value of b, minus 12, don't forget that minus, is our constant, our value of c. So a was 6, b was 1, c was minus 12, and we get 4/3, press equals again, and we get minus 3 over 2. So sine theta here is either 4/3 or minus 3 over 2. Remember, we're showing that there's no solutions. So we need to think about these numbers. Are they possible? Can sine theta equal 4/3? Can it equal minus 3 over 2? Well, the answer is no in both cases. So there are no solutions because, and you will need to give a reason, even though the question doesn't ask for a reason. Maths exams are all about showing understanding. So you need to say why there's no solutions here. I'm going to say no solutions because sine theta has a range of minus 1 to 1. And therefore, we're not going to get any solutions to it equaling 4/3 or equaling minus 3 over 2. Now for part B, which has nothing to do with part A, find all values of x between 0 and 180 degrees satisfying this equation. So I would do a substitution here. Let 2x take away 75 degrees equal some other letter. Now I could use theta, but then I might start thinking it's the theta from part A, so I'm not going to use theta, I'm going to use y. So now solve sine of y equaling minus 0.515. And very important, you think about what the range would be. If x is between 0 and 180 degrees, then what would y be between? Well, y is double x and then take off 75. So we can do the same thing to both sides of the x interval. So double 0 and take off 75 gives me minus 75. And then double 180 and take off 75. Which is 285. So that's what we want y to be between. Because then at the end of the question, when we add on 75 and divide everything by 2, it'll get us back into the range 0 to 180. Quick sketch of the sine graph. There it is, just a rough sketch. I've drawn a bit more than I need. I've gone back to minus 90, so this minimum point here is minus 90. I've gone all the way up to 360, although I don't actually need to. So now minus 0.515, going to put that on my graph. There it is on my graph. I can see there's going to be 1, 2, and probably not 3 solutions, because I know this here is 270 degrees. So this final one might be smaller than 285, but it might not be. I'm expecting it probably isn't, but if it is, we'll include that as well. So to the calculator, inverse sine of minus 0.515, making sure you are in degrees mode, look for the D on the screen. It's inverse sine. It's a relatively common mistake to forget to do inverse sine and just do sine. So make sure you definitely do an inverse sine. And we get minus 30.997. I'm not going to round that number yet, because at the end of the question I'm going to be adding 75 back on and then dividing everything by 2. So I'm going to be careful not to round this. So I'm going to store it under X. 2 buttons, STO button, and then the X button. That number is stored under X. So on the screen this is minus 30.99. So if I did a full 360 added onto that, so a full 360, that would take me here. So if I add 360 onto that, I see that third value turns out to be 329. It is too big, so I'm not going to include that one. So there will only be 2 values. First one, make sure you put y equals, not x yet. So we've got minus 30.99 blah 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 stored in the memory. And then the next one, the one that's slightly bigger than 180, using the symmetry of the graph, well, between a crossing of the axis and that value is 30.99. So by symmetry, between a crossing of the axis and that value will also be 30.99. So the next value is going to be 180 plus 30.99 blah blah blah. Now I just need to be careful here, because in the calculator I stored, and if I use the recall function here, I stored the minus along with x. So if I typed 180 plus the number I'd stored, it would actually take it off because it's negative. So on the calculator I need to do 180 take away x, and my x was negative, so this is going to make it do 180 minus 30.99. So I'm going to store this second value in the calculator as well. I'm going to store it under B, no particular reason. I'm just going to go with B. So 2 button clicks, store B. You do not need to use the alpha key when you're storing. If you can use the recall function to check, yeah, I've got minus 30.99 stored under X, I've got 210 stored under B. There's no particular reason why I chose those two letters. So let's finish off the question. They both equal 2x takes 75. So add 75 onto both of those and then divide them both by 2 and we get our x values. So clear the screen. So the minus 30.99, which I've stored under x, add 75 and then divide the answer to that by 2. So don't just divide the 75 by 2, divide the whole thing by 2 and we get our first angle. It didn't say how many significant figures, so the standard thing is to go with 3. So 22.0 significant figures, and then the other one, this 210, just checking, I stored it under B. So I just use the arrow keys and change that X into a B using the alpha key, and that gives me the second one. To 3 sig fig, that's going to be 143 degrees. And that is part B done. Remember, you check your answer by putting those answers into the original question. And if the equation works, then you know they are correct. Part C was to solve the equation 4 tan phi plus 7 sin phi equals 0 for values of phi between 0 and 180 degrees. This symbol is phi phi. So nothing's squared here, so I'm not going to try and use the sine squared x plus cos squared x equals 1 identity. Instead I'm going to look at the other one, sin x over cos x equals tan x. So I'm going to start by replacing tan phi with sin phi over cos phi. Now rather than rearrange the equation and take things away from both sides, I am going to multiply the whole equation by cos phi. That will mean we don't have any fractions. And also you've got to be careful when you're timesing both sides by an unknown. You need to make sure it can't be 0. So if you times both sides of an equation by 0, we have problems. In this question, I can be confident that cos phi isn't 0 because it's in the denominator here, and dividing by 0 is impossible. So I'm safe to multiply both sides by cos phi. Next step is to factorize our common factor of sin phi. Don't go dividing by it. Do not divide by sin phi, because dividing by 0 is impossible. And in this equation, sin phi could be 0, because it works. If sin phi was 0, put it into the equation, we get 4 times 0 plus 7 times 0, which does equal 0. So do not divide both sides of the equation by sin phi, because in this particular equation, sin phi could be 0. Instead, bring it out as a common factor. Now that it's fully factorized, we can see we have two possibilities. Either sin phi is 0, like I said a moment ago, or the brackets equal 0. If the brackets were 0, then cos phi will be minus 4 over 7. Next I'm going to draw a quick sketch of the cos graph, only from 0 to 180, that's all I need. So cos between 0 and 180. So where would cos phi equal minus 4 over 7? That'll be down here somewhere. So we can see there's only going to be one solution to cos phi equaling minus 4 over 7. Let's get that value now. Make sure your calculator is in degrees and do inverse cos of minus 4 over 7. And the question didn't specify how many decimal places or significant figures, so let's go with 3 significant figures. So from the graph we get phi is 125 degrees, that's to 3 significant figures. We can see from the graph only one value between 0 and 180 for cos phi equaling minus 4 over 7. We mustn't forget the other one as well. I'm not going to sketch the sine graph, just think what it looks like and then write down all the points where it crosses the x-axis or the phi axis between 0 and 180. So sine of 0 is 0, so that's a solution, and also sine of 180 degrees, and we're including both of those values in this interval. So that's it, 3 solutions, 125 degrees, 0 degrees, 180 degrees. The first one there rounded to 3 sig fig, but the other two are exact.